All right, here we go, here we go. So, this warm-up is like the one we did the last couple days. All right, so remember, we need the base to be the exact same, right? The base is not the same, right? Right now it's 5 and 625, which are not the exact same, right? Over here. So, what do we got to do? We got to turn this 625 into a 5, but what power would that be? So 5 to what power gives you 625? You say 5 to the 4? Okay, well, let's find out. Again, everybody, we need to have the same base. Take the bigger one and see, does 5 go into 625? Like 5 to what power? So we're going to try 5 to the 4 power. Let's see, 5 caret 4. That's it. Okay? Sometimes you might have to guess and check like this, but 5 to the 4 is 625. So we're going to rewrite 625 as 5 to the power of 4. So let's go ahead and write that. So this is really 5 to the 4th power, and then bring down that to the negative x power. The left side is not going to change. It's already 5. So I'm going to put 5 to the 2x plus 1 power. Now, are the bases the same now? 5 and 5. Yes. But over on the right, the 4 is to the power of negative x. U. So what do I do with these two numbers? What do I do with the power to a power? Distribute and multiply. 4 times negative x is what? But there's a negative sign, so negative 4x. The other side stays the same. 2x plus 1 is in the exponent. Now we can see that the bases are exactly the same, and they have different powers. Step 2 is when you are, because you got 2 headphones in your ears. Can you take those out? Can you please take them out? Can you please take them out? The headphones? No, you're goofy. All right. You're goofy.
Your team.
All right, now, once we get rid of these bases, we're going to set these equal to each other. So we get, 2x plus 1 equals negative 4x. Don't ask. Just do your warm-up and, wait. No questions. I'm not taking questions at this moment. Headphones, please. Wait. So if x is on both sides, I want to get rid of the smaller x, right? Which x is smaller? Okay, negative 4x is smaller, so the opposite is to add 4x to both sides. All right. Now I got questions for you. If I cancel everything out on the right side, what's left over? If I cancel out everything on the right and there's nothing left, what do I write? 0. Bring down, what's 2x plus 4x? 6x plus 1 comes down. Now, can you solve a two-step equation? I bet you can, right? How do I get rid of that plus 1? Minus 1 on each side. What's 0 minus 1? No. Negative 1. And then how do I get rid of the 6 in front of x? Divide, right? Anytime you're getting rid of a coefficient, you divide. So we divide by 6, and I get negative 1 over 6. I know it's a fraction, but that'll do, okay? Since we do not have school on Friday, which is usually the day we pick these up, make sure you put Good Friday for tomorrow. If you were absent, put absent the days you were absent. Make sure your name is on it, because last week someone turned one in with no name. I don't think so. I'm not sure, but I don't think it was. Maybe. You can check the red folder over there. All right, I'm going to come pick up these warm-ups after I pass out today's notes. I know. Because y'all love it, I hate it.
supposed to, then warm up.
Just put absent if you're absent. Were you
I
absent?
was here.
Then why did you do it?
Because I forgot to write it.
Forgot. Oh, forget.
Yeah. Oh. Did you? Sorry, you really want to track these hands. I didn't see this
All right, warm up. Check it out right now.
Hey, I'm writing my name.
Name's right there.
Hell no, you're not allowed to call me that.
Okay, well, I'm just reading it. Isn't that what I say?
Where'd you get the I from, huh?
It's earn and then there's an E. Warm up.
So you're gonna have these hands. Hey, can you do a flip?
Huge.
So if we do a flip, I'll give you $20.
All right.
So yes.
You better not walk.
I won't.
You better run on over. Don't walk.
I was doing it on this.
All right, here we go. Let's do these notes. Wait a minute. Yeah, this is it. Okay. Everyone's looking up here. I know it's end of the week, but it's still Thursday. Let's focus and get these done. By the way, we're not going to get these done. We're going to do as much as we can, but we're probably going to stop at example 2 on the back, not the front. Okay. All right. Here we go. 9.3 notes. This slide is everything we've already talked about. So you should already know that exponential is increasing values over a period of time at a constant rate. A times b to the x. A is the initial value, and b is the growth factor if it's greater than 1. So like 2, 1.5, whatever. Okay? And you can see what it looks like. This is growth. It goes up to the right in a curve. Then over here, we know exponential decay is decreasing constantly over time. A times b to the x. A is the initial amount. B is the growth factor. But it is positive and less than 1. Does everyone see this? Decay, this b value, must be less than 1. 0.1, 1/2, 2/3, 0.75, something like that. Okay, so this is old news from 9.0. Let's answer these questions. And if you were doing lead time today, this is what you did during lead time probably. So, is this exponential function growth or decay? So don't look at the first number. Is the second number bigger than 1? What? 1.78? Yes. So that means it's bigger than 1, growth. Okay, so this is growth. What about the one on the right? Look at the second number. Is this growth or decay? Why is it decay? 0, not just decimal. 0.48 is less than 1, right? Hey, put that away. No, put it away. Hey. Don't do that. No texting. Yeah, don't have friends. Not right now. Okay, now, next part. What is the initial value? What is the very first number you see in this equation? 0.6. 5.6 is my initial value. What about the other one? 120. Cool. Now, this is where it's very important. I want everyone to lock in over here, looking over here. What is the growth factor? So what is the second number? 1.78. What about the second number over here? 0.45 is good. Now, I want you to notice there's a difference between the factor and the rate, okay? So, factor and the rate. The factor is what's already there. To get the growth rate, go and write this down below it, okay? The rate, you're going to subtract 1, okay? Subtract 1, okay? So notice what they're going to do here. They're going to take 1.78 minus 1. Whatever's left over is called the rate. Okay? So 1.78 is the factor. Take away 1. 0.78 is the rate. Okay? Does everyone see that you have to underline it? Subtract 1. If you don't subtract 1, that's not the rate. Okay? Right, Mike Scott? Now, next one. What is the rate? So I'm going to take this growth factor and do what again? Subtract 1, right? So once again, I'm underlining this. I'm making a big old underline, thick old underline. If you don't subtract 1 from the factor, you're not going to get the rate. So whatever the second number is, you subtract 1. In this case, 0.45 minus 1 gives you a negative number, and that's okay. It's decreasing by 55%. This one on the left is increasing, because it's positive, by 78%. They are different. Okay? Okay, everyone good so far on the front side? Oh, on example 1. Let's look at example 2, okay? Everyone needs, capital N needs a calculator to do the next part. So make sure you got a yellow, oh, there you go, yellow calculator. Who does not have a yellow calculator? All right. Okay, example 2. I know there's not a picture here, but look at these numbers. As x is going up, 0, 1, 2, 3, 4, 5, 6, what's happening to the y values? Going down. What do you think that is? Decay, right? As the x goes up, if the y goes down, that's decay. Okay. Now, here's the dealio. We need to find the equation. So what I'm going to do is I'm going to drag this over here. Okay, can everyone pull up your calculator for me, please? Okay. We are going to do what's called a regression. Have y'all ever done this in the spreadsheets where you do menu 413, menu 416, menu 41A, something like that? Okay. So go ahead and press new document. Don't save. Number 4, add lists and spreadsheets. Okay, so we're going to go to lists and spreadsheets. Those of you who've done this before, what do you have to do first? Okay, X and Y have to go at the top. If you don't put X and Y at the very tippy top, it's not going to ever work for you. Just saying. So remember, I'm going to write this down, X and Y at the top. Okay, so I'm making notes on my notes at the top. So I'm putting X, I'm putting Y. Then you skip that gray line, and then you start down here where the number 1 is in the white boxes. And in these boxes, you're going to put this whole table. Can you go ahead and fill in that table for me? Is everyone doing this with me? So that way in the future you can do it yourself. I'm going to start tapping this in. Here we go. To the right. Now, right here it tells you what buttons to press. You understand? Are you trying it out? Menu 41A. A is for exponential regression. So I'm pressing menu 41. A at the bottom says exponential regression. Now right here, you actually have to do something. If you just press OK, it's not going to work. X must be X and Y must be Y in the first two boxes. X is X, Y is Y. What has everyone else got in their hands that we're supposed to be doing? The yellow calculator that you don't have on your desk. Can you go get that, please? Thank you so much. Go. Do what you're supposed to do. Come on, go. Oh, because we're still like in this box. So here's my enter. Yeah, when it's a blue box, it should work. That's so adorable. So X is X, Y is Y. Hit OK. Now, when you do that, I need to know A and B, and I can't see A. Right? It's not even him. Don't do that. All right, A and B. So you have to go up to A. Can you turn that on and stop doing weird stuff? All right, so. Yes. So A, listen, A is 100.326, which we can round to 100.32 actually. And then B is 0.876. The 6 will make the 7 round up to 8. However you want to round it, because we didn't tell you how to do that, but it's going to come out to this stuff right here. Okay. This is what we get. So make sure you write that down. Now, which one of those numbers is the initial value? Which one? The one to the right. Right? Tell me the numbers. $100.326 is my A value. That's my initial value. That's good. What about my growth factor? Okay, 0.87 is the factor. The rate is when you subtract it from 1, or subtract 1 from it. Okay? But the factor is whatever's there, 0.87. Okay, so what you can do is flip your paper. You do not need the growth rate. I mean, if you want to write what's the rate, you could do 1 minus 0.87, and you would get negative 0.13. No. Okay. It's not supposed to be on your desk. Okay, flip it over, please. Now, everybody, can y'all write small, hopefully? I want you to write these everything that you see in blue in each of these little boxes. I know it's going to be small. Just do your best. So again, this. I'm going to give you a few minutes to write in these titles into these boxes, okay? Let's see who's not writing that. Write small in the boxes, and you know which one is which, right? I'm listening to sea shanties. I'm listening to sea shanties. Which one? I know them all. Sea shanty. It's a marine. It's a concept for me. That's okay. Well, legit sea shanties. Like,
I like it. Megabyte? I listen to these with a problem. What's your favorite? Shut up, Colin. Why are you hating on me, bro? I can. It's illegal.
Oh, yeah, it's not.
Get you. I want to move schools now. Please. I'm going to move Louisiana.
Why'd you stop it?
That's the only approved music in this house. Alright, so does everyone have the blue parts written down?
No.
We can all sing it as a sea shanty. Increase, appreciate, inflation, doubling, population increasing, right? Alright. Alright, let's do some examples. Oh, you weren't ready?
Yes.
Oh, I'm sorry. Let's get ready. What are you doing? What are you listening to?
Nothing.
That was the wrong answer.
Probably she shanty.
I gave you the right answer and you said the wrong answer.
Oh, I mean sea shanties.
Oh, which one?
Yo. Oh, you mean just sugar and tea and rum?
Oh, okay. Don't talk about that at school. That's inappropriate.
It's alcohol free,
All right, we'll call it juice. All right.
but it's rum.
No, no, no. All right, we done?
No. I'm writing the longest one. Go ahead. Stop being selfish.
All right.
Shut up.
Whoa, whoa, whoa. Be nice.
Yeah, there it is. Colin, again.
Whoa,
Shut the
whoa.
hell up.
No names.
Oh my God.
Be nice.
Did you just say the H word?
Shh. No. No.
Okay, I'm on the last.
You have like 20 on your desk.
No.
Here we go. Example 1. Ready?
Oh my goodness. Can I at least take a picture?
Yeah.
Change. I'm sorry, I read slow when I try to write small. Are you doing that on purpose? Okay.
All right. Example 1. Now, we need to reference what we just looked at as we're doing this. Let's read this. Tom bought some machinery for how much money? $60,000. The machinery is expected to what? What's the word? What's the word? Depreciate. Everybody underline depreciate. Do you think that makes it worth more or less? Less, like the US dollar, depreciating. All right? So, shh, be nice. No, you. Be nice to him. At an average rate of 10% per year. Okay? So we have a rate, underline the rate, underline the original money. What is the value of the equipment in 8 years? Now, the key word was what here? Depreciate. Let me go back a slide. Which one of these says depreciate? Top right, right? Does everyone see depreciate up there? Okay. So we're going to use that formula. Does everyone know what P stands for? Off to the right, it tells you P is what? Starting amount. What is R? The rate as a decimal, and T is time. Okay, does everyone see that on your little... Okay, let's go ahead and start filling this in. What is the initial value? Everybody, what's the initial value? 60,000. Thank you so much. Don't say that. What's the rate?
10%.
Now, is it positive or negative if it says the word depreciate? When you think of depreciate, you should think of a negative value. You're losing value over time, right? It's a negative 10%. Now, this is something you should have done in middle school, but I know, stuff happens, like crazy stuff. Does everyone know how to turn a percentage into a decimal? What's the rule? Move the decimal to the right is so wrong because it's left. Okay? When you're getting rid of the decimal, when you're getting rid of the percentage, you move it to the left. True, but it's 100% wrong now. So, now, if you were taking a decimal and making it into a percentage, then you would move it 2 to the right and put a percentage sign on it. Hey, can you turn that off? That you shouldn't even have, but you sold yourself out because I can hear it. You know what I'm saying? So, what's the equation? Oh, wait a minute. What's the equation? Y equals what? P parentheses 1 minus R to the power of T. We know P is 60,000. We know R is 0.10. We're subtracting. And then what should I put for T? What should I put for T? T. 8. So if I plug in 8, because T is 8, I'm not going to type it in for you, but if you were to type that into the calculator, you would get 25,828. All right. Do you understand how that works now? What did you say? Say yes. Now, the next one. In 1970, a Reese peanut butter cup candy bar cost how much money? What is this? 25 cents because they'll do that in decimal. 0.25. For a quarter, you couldn't get a peanut butter cup. If the rate of inflation was 3% every year, how much should the candy bar cost today? What's the key word here? How do I know if it's going up or down? What's the key word? Inflation. What does inflation mean? Okay. Going up, right? So that means the prices goes up, like all the prices of our groceries today, for some reason. Wow. Wow. Now, everybody, inflation does mean going up. Depreciation does mean going down. Now, let's go ahead and underline some things. The cost, the initial value is 25 cents. The inflation is at 3%. How much should the candy bar cost today? So what do I write for initial value?
45 cents.
So close, except it's not 45. It's 25 cents.
No, we're talking about in general.
Oh, should? I don't know. Okay, so 20. No, we want. Okay, we're talking about Reese. Reese peanut butter cup. Just Reese. One Reese. Now, what's the rate here? 3%. Now, you can write 3%, but below it, what's the rule? What do we do with the decimal? To the left, okay? If you're getting rid of the percentage, you move the decimal 2 to the left. So if I do that, I have like an empty space here. What goes there? What goes in this empty space when I move it to a 0? So it's going to be 0.03 is my rate. And is inflation positive or negative? Positive. Okay. And then the equation. Now let's go back in time a little bit. Back. All right. Which one of these says inflation? The first one. So let's try that. We're gonna fill this in. So it's gonna be P first, which we know is 0.25, then 1 plus R, which is 0.03, to the power of T. What's the T gonna be? Now y'all need to put on your thinking caps. Does it tell us how many years? No, not every year. From 1970 to today. How many years is that?
43 years.
Close. What?
43 years.
No. 53 years. Okay. It's 30 years to get to 2000, and it's 2023, so you add 23 to that, you get 53. Who's blasting music over here? Someone's blasting music. Seriously, who's blasting music? Turn it down. No, wait, sorry. Turn it off. Okay. Sorry, my bad. I was wrong. So 53, if you plug it in, oh, that's a typo. You too. Yeah, right.
That's this one, shoot.
Ooh.
Oh, you snitching now, huh?
Shut the hell up,
Shh. That'd be nice. That's literally what today's all about.
I would never. Good.
No, it's Maundy Thursday. I'm glad you asked.
Now I'm great asking because I feel like you have to give us a whole lecture.
Yes. Since you finally asked, no one took the bait earlier. Maundy?
Oh, dear God.
Speaking of which, tomorrow's Good Friday. What happened on Good Friday?
The meal, the final one.
That's today.
Oh, yeah, he died at the cross.
That's on Friday.
The
So
part, so
during the meal, he said, "I give you a command, Maundy, a command to love one another, to be nice to one another, right? Maybe we should don't do that.
I do that all the time. That's
Come
what
on, me.
I agree people with this.
No, y'all are killing me. Okay, so let me.
so easy for giving most people except that guy and my dad.
Okay, just do better.
That guy has a damn name.
Okay, be nice, be nice. Okay, we're gonna call it a day there, because the other period didn't get past this point.
Okay.
And that guy did.
Take right now. Because everybody seems to be that. Yeah, pretty much.
All right.
No.